Hello everyone. Before continuing on, make sure you have this handout printed. In this lesson, we're going to start our study of chemistry. And to start our study of chemistry, we're going to look at the particle theory of matter. So it's important to understand what we're talking about, so we're going to start with terminology. And we're going to look at this word here. So matter is anything that takes up space and has mass. You can think of it as taking up space as volume, and mass is having weight. So matter is anything that takes up space, has volume, and has weight, mass. So it's important that we can come up with some examples of what matter is and what matter is not. So some examples of matter: things that take up space or have weight to them. Things like water, soil, wood, metal, air even. People don't think that air is matter, but it has a mass and it takes up space. Things that are not matter would be things like light. You can't weigh light on a balance. Heat. Heat doesn't take up space. It doesn't have weight or mass. Any form of energy, sound energy, electrical energy, none of that is matter. So matter is anything that takes up space and has weight or mass. Anything else that doesn't have weight or mass and doesn't take up space is not matter. So what we are talking about in chemistry is the study of matter. Chemistry does not look at these things which are not matter. It's the study of matter. So let's continue. Now we're going to zoom in on matter, and we're going to look at something called the particle theory of matter. Basically, the particle theory of matter says that all matter is made up of small particles. Think about any piece of matter, a piece of wood. You cut the piece of wood in half, then you cut it in half again, then you cut it in half again, and you keep cutting it in half. Every single time, the piece of wood becomes smaller and smaller and smaller, until eventually you get it down to a piece that you cannot cut. You're at the smallest possible piece of that matter. And that's what these particles are. So the particle theory says all matter is made up of extremely small particles. Now these particles have names. We call them atoms or molecules. And we'll talk more about that later. But these particles, these smallest pieces of matter, they are in constant motion, which means they are always moving. These particles are held together by very strong forces. Think about a chair. The chair that you might be sitting on right now is held together. All of the chair particles are held together. The chair isn't exploding randomly because the particles are attracted to each other. They stick together. Now, if we look at the particles, there are empty spaces between those particles. They're not all jammed together side by side. There's empty space between the particles. And these spaces are very large compared to the size of the particles themselves. So the picture is you've got these really small particles with huge spaces in between. Each substance has unique particles that are different from the particles of other substances. So the particles in your chair are different from the particles in your bed, and those are different from the particles in your sweater, and those are different from the particles in the water that you drink, and those particles are different from the particles in your skin. Each substance has unique particles. So if I were to draw that, I would have substance A has particles that look like this, and substance B has particles that look different. The other thing with particles is that temperature affects the speed of the particles. So what I mean is, as you increase the temperature, the particles will move faster. As you decrease the temperature, the particles will move slower. These particles are moving all the time because remember, they are in constant motion. But you can change how fast they're moving by increasing or decreasing the temperature. And this idea that you can change how fast the particles are moving goes into states of matter. Matter can be found in different states depending on how much energy it has. So the amount of energy dictates how fast the particles are moving. The more energy, the faster they move. The less energy, the slower they move. And if particles are moving really, really fast, they're going to take up more space. And that's where we get gases. If particles are moving really, really slow, they're going to take up less space and they're going to be closer together. And that's where we get solids. And in the middle, we have liquids. So we can see the different particle arrangements in solids, liquids, and gases as shown in my diagram here. So these are representing a container of some sort that's closed at the top. The gases take up the entire container because they have lots of space in between the particles. Solids, on the other hand, they don't take the shape of the container, they just stick together in one spot. Liquids start to take the shape of the container, but they won't fill the entire container because the particles are still pretty close together. So imagine you have a chunk of ice, an ice cube in a container, and you want to turn it into liquid water. What do? Well, you add heat. So as you travel from a gas to a liquid, you have to add heat. And this process is called melting. Now you have that liquid water. If you add more heat, eventually it's going to boil or evaporate. So as you add heat, this is called evaporation. When you turn a liquid into a gas, we also call it boiling. Now you can turn a solid directly into a gas by adding heat as well. That process is called sublimation. Now that's all the changes of state when you're adding heat. What happens when you remove heat or you cool things down? Well, if you cool down a gas, it's going to undergo the process of condensation and turn into a liquid. When you cool that liquid down, that's the process of freezing, and it turns into a solid. And just like you can go directly from solid to gas, you can turn a gas directly into a solid without turning it into a liquid first. And that process is called deposition. So you can change the arrangement of the particles by changing their speed. The faster they move, the more spread out they are. The slower they move, the more clumped together they are. And how close the particles are determines the state, whether it's a solid, a liquid, or a gas. So you can use this idea of the particle theory to answer the questions on the next page. So you have these practice questions here. So for each observation, I want you to draw the original arrangement of the particles and then what happens to the particles afterwards. How's the speed of the particles changing? Why is the speed of the particles changing? How's the spacing between the particles changing? And what's that process called? Do that for both of them, and then you can check your answers.